In this video, we're going to take a look at some of the basic types within Go. I've got a simple Go program here, and let's go ahead and start with the integer type. So I'm going to declare a new variable. I'm going to just call this iNumber for integer number. I'm going to define it as an int, and I'm just going to set it to be 1. In Go, the type of the integer will depend on your particular machine. For me, because I'm on a 64-bit machine, this is going to be a 64-bit integer. If you're on a Raspberry Pi, for example, it will be 32 bits. Now, you can, of course, explicitly define the size of the integer. So you can do int64, and that will be a 64-bit integer. You can also do 32. Again, it's going to be 32 bits, 16, and 8. One thing to note is if you do use an int 8, for example, the max you can do there is 255. So if we were to do something like inum equals inum plus 1, it's going to complain because I don't know if we can see the full error there, but it's going to complain because that's going to overflow. Because you can only store 255 in an 8-bit integer, it's going to overflow, and you'll get the compiler error of numeric overflow. And I believe you can go look at the actual type error in the Golang docs if you want to do that. Okay, so let's set this back just to be an integer. With integers, you can also set them to be negative if you want. So this can be -10. And that's basically all you need to know about integers. There is, of course, the unsigned integer as well, which will just be uint, and this is always going to be a positive number. And again, you can just set that to be whatever you want it to be. Equally, again, there is unsigned int 64, 32, 16, and 8. And that's pretty much all you need to know about integers. You've got ints, you've got unsigned ints, and then you can define the bit size of that particular int. Again, the default will depend on your machine size itself. And it's also important to note that the int is basically the default type for integers in Go. So if you ever define the length, for example, a equals the length of a particular slice, this a will be an integer. Let me get rid of those and let's take a look at floats now. So let's do fnum, and we'll sign this to be a float 64, and we'll set that to be 1.3, for example. So in Go, you've got float 64 and you've got float 32. They're the only ones you can do. There's no 16 or 8-bit floats. Equally, there is something called a complex. So let's do var cnum, which is going to be a complex 64. And I've never used these personally in any of the code that I've written, but it's good to know that they exist. And equally, there's the 128-bit complex number. And I believe these are for like imaginary floating point numbers. I've never used them. You may want to use. Not particularly related to Go, but just a general programming thing is if you're ever doing monetary calculations, don't use floats, just use integers and store it as pennies rather than dollars. Just a little side note there. Okay, so again, one thing to remember is that if we create an integer number here, let's say int1, we can't do operations like adding the fnum to the int num. We couldn't do this. I mean, it's kind of auto completed there for me, but you can't do this here. It's going to complain as we've got mismatched types here. But what you can do is you can cast one of the values into the particular type you want. In this case, we can cast our integer number into a float 32, and that will add both of those numbers as float 32. Okay, let's just do a quick little example here of how floats and ints interact, just to see what happens when you kind of do the casting and all that kind of stuff before we move on to strings. So we've got here our integer number and we've got our float number here. So if we go ahead and cast our float number to be an integer number, so let's go ahead and cast this to be a integer. So we're going to cast our fnum here. So we've got the float number of 1.3. We're then casting it into an integer number. Let's go ahead and just print out the fnum. So we'll print that out there. And then if we print out the integer number here, save that. If we go ahead and run this particular program, we'll see that we start off with 1.3 and then we end up with 1. So when it's a float, we have the numbers after the decimal, the 0.3, sorry. And then when we cast it to an integer, because integers are whole numbers, we can't handle the floating points, we end up losing the precision of the 0.3. If we were to go ahead and do this in the inverse. So let's do, again, back to float, can't type, back to float. And we were to cast that back to a float 32, and we were to run this. Again, it's just going to be back to 1 because we can't keep this 0.3. Basically, when you do the casting, in the memory, that 0.3 is just removed and lost. It's not going to track. So just one thing to note about if you're converting floats to integers, you will lose that precision value. Let's now take a look at strings. So I'm going to create a string S here, which is going to be of type string, unsurprisingly. And as I'm sure you guessed, this is going to hold a string itself. And we'll see, we'll hold the word hello here. If we go ahead and print out this string here, and we can run this code, and we'll see that we get the word hello. In Go, you define strings with the double quotes. If you want to have a multi-line string, for example, hello world, you can't use the double quotes there. You have to use the backticks, and at that point, it will print out the word with the spacing as you expect. If you want to use double quotes, you can use the line break key there, and that should then print that out with the space between them. Another thing you can do with strings in Go is you can concatenate them. So if we break this up and we create a space between them, we can then do that and it will print out hello space world as we would expect. So strings are pretty straightforward, nothing too complicated about them. It's just important to remember the double quotes can only be on a single line. If you want to have multi-line comments, you use the backticks. If we go ahead and do something here, let's print out the length of our string S. And we should get a number out here. So we get 11. One thing to note about the length here is it actually prints the size of the string in bytes. So you can see here it says, string, the number of bytes in V. So it's not going to print the actual character length. It's going to print the byte length. This does mean that if you use a special UTF-8 character here, for example, this strange F character, it's no longer going to be 11. It's going to be more than that because that's not a single bit. Just an important thing to note, if you ever run into cases where you're getting a weird length of a string, it's because it's the bytes, not the actual character. If you do want to calculate the length of a string correctly, I believe you can use the UTF-8 package. And I believe there is something called rune count in string. And this will basically give you the actual count of the characters rather than the bytes within the string. So if we go ahead and do that again, it's now 11 rather than 12, even though we've got this Unicode character in our string here. Just to kind of gotcha that one, so make sure you are aware of that, as you may run into some weird bugs on Unicode characters in your strings if you're looking at the length. The other thing to know is Booleans. So obviously let's do my bool, and again it's going to be a Boolean type, and this is either false or it's true. Okay. Booleans are pretty simple. Once you know it's false or true, it's pretty much. Okay, so now we've looked at strings, let's have a look at some declaration syntax. We've covered this a little bit before, but let's go into a little bit more detail. So you can obviously do var int, which will be declaring an integer here. In Go, there are no such thing as undeclared variables. They're always declared with a default. So for integers, it's always 0. For floats, it's also 0. For a string, so let's do string, var s, which is a string, it will always be a blank string like that. So you can definitely do this explicitly, but just know that if you ever declare a variable without assigning it, it will always have a default, and the default is either 0 for an integer or a float, empty string for a string, if I can spell correctly, and then I believe everything else is defined as nil. So that's one way to define variables with the var keyword. Another way you can do this is multi-line. So you can do, let's do this, if I could type, you can do var b equals 1, you can do c equals 1.1, and that's totally valid syntax as well. Okay, another way to declare variables that you've seen in the code before is using the colon and then the equal. So if we do t equals this is both declaring and assigning the variable t to the value 1. And it's going to implicitly work out that t is an integer. You cannot do this syntax outside of a function. It always has to be within a function itself. So let me just go ahead and delete these. So you'll see that, let's just go print this out so that we have the errors. T. So you'll see here that syntax is absolutely fine, but if we move it outside of here, it complains, and that's because you can't use this simple declaration outside of a function. In terms of other ways you can define variables, you can do sort of var1, var2, and again, you can do that same syntax and set multiple variables at the same time. And again, this is equally valid syntax. Just do var1, var2, and you can see that's absolutely fine. Compiler is okay. So one thing to note with Go is that you want your code to be very simple and very readable. So let's say you were importing and using a function called blah and assigning it to be foo. If you're not entirely sure of the return type of blah, it would always be worth defining the variable with the type explicitly, just to make things clear and more readable and more understandable. Okay, so the final type we're going to cover in this video is the constant type. So this is an immutable type that you cannot change at all. It can be a string or an integer, I believe it can also be a float as well. So we set this to be a constant. And if you try and change this, the compiler is going to complain. It's not going to allow you to change a constant as they are entirely immutable. You cannot change them at all. And one thing to note is, again, I believe they can only be a integer or a float or a string. I don't believe they can be things like slices, for example. So if we do like var s, let's say it's a string, and we assign it to be this. If we try and change if we try and create a new constant of s const, I don't believe we can make it to be a slice yet. We're not allowed to do that, and I don't believe we can even do that, like the index of a slice as well. Yeah, the variable type string is not a constant, and it's saying that because it's basically the string within a slice rather than the actual raw string value itself. We could of course do that, and that would be absolutely fine. Constants are pretty useful. It's just important to note, again, it can only be a string, an integer, or a float, I believe. I believe it can be a float. Let's check 1.2. Yeah, so it can be a float as well.